Hello, boys and girls. It's Mrs. Vernetti here, and today we're going to use the 20 bead Rekenrek to help us build some different numbers. I'm excited to find all the different ways that we can build numbers, such as 10. We're starting with 10 because I think you know your pairs to 10 very well from kindergarten. What are some of the ways that you could build 10 on this 20 bead rack? Did any of you think 5 and 5? 5 plus 5 is 10. So that's one way that you could build 10. What's another way that you could build 10 on this Rekenrek? Oh, yes, absolutely. The quickest way is to just move one whole row of 10 across the top. Good job. So we could say that 10, if we're looking for two addends, plus 0 is 10. What's another way that you could build 10? Are you saying 6? Okay, so if I have 6 on the top bar, how many more would I need on the bottom bar? 6 and 4 makes 10. And of course, boys and girls, the wonderful thing that you've learned is that we can just flip that around. We can put 4 on the top and 6 on the bottom, also making 10. These are the same addends. They're just flip-flopped in a different order. Are there any other ways you can make 10? I'm sure there are, but let's move on to a bigger number. We've just found lots of ways to make 10. Let's try 13. How would you make 13? In my brain, I always see 13 as a T number, which is 10 and 3. So I would move 10 over on the top bar and 3 over on the bottom bar. Any of you do that? 10 and 3. But are there other ways that we could make 13 besides 10 and 3? What if I wanted to do 10 and 3, but I wanted to have all 10 red beads and 3 white beads? If I did that, then I have 10 and 3 still, but it's on different rows. How many are on this top row? I have 8 on the top row, and then how many on the bottom row? 5, all 5 red beads. Does that mean that 8 and 5 also makes 13? Are there any other ways you could make 13? Give it a try. Let's see. I like that idea. I never thought of that before, of sticking with my 10 and 10. What is another way I could move? Let's see, if I have 10 here and I need 13 altogether, I'd have to move 3 more over. So in the 8 and 5, I moved 3 over. What if I just moved 2 over? Is that 13? There's the 10 and 2 more. I would need 1 here. Is that still 13? 5, 10, 11, 12, 13. It is, but now I have different addends in each row. What have I got? Can you count them? I've got 7, 5, 6, 7, and then I've got 6. Wow, lots and lots of different ways to build the number 13. Can you think of another way? I know that first graders love to use the number 9. Let's see if we can do that. If we have 9 in the top row, how many more would we need to get to 13? Well, let's see. 9 and 1 makes 10, and then 3 more. So how many do I have in the bottom row there altogether? I've got 4. 9 plus 4. Is it true that all of these expressions add up to 17? Pretty cool. I think we should do one more, maybe 2. We'll see. Let's try a different number. The next number I want to try with you is this, 16. 16 is a little bit bigger than 13. And you can think of some different combinations we could make to 16 while I erase the board. How would you build 16? Of course, there's the one that my brain always goes to first. Maybe not yours, but my brain always goes to 10 and 6. If I move over 10 on the top row, 10 and 6 more makes 16. What's another way that you could make 16? Why don't you pause the video and see if you can come up with 2 more ways to do 16, 2 different ways to make 16. Let's do the 10 here, and then I need 6 more. What if I did, no, that would give me the 10 and 6. What if I did, I know that 6 is 3 and 3. What if I did 3 on each row? Ooh, is that 16? What do I have on the top and the bottom row? I have 8 in both. Boys and girls, this addition fact has a special name. What do you notice about the 2 addends? That's right. Both addends are the same. We call this a doubles fact because if you have 1 8 and you double the 8, 8 and 8 is 16. You could say double 8 is 16. Let's do this. Miss Keith always used to teach me, you can give one to get one, and the sum will stay the same. Let me show you what that means. If you give one of these on the bottom row back, and you get one on the top row, and they trade places, then you still have the same sum, but now we have 2 different numbers. What have we got here? Can you count the numbers in the top row? I've got 9, and then the bottom row, let's see, 5, 6, 7. So that must mean that 9 plus 7 is also a pair of addends that get to 16. Could we do it a different way? Could we do, let's see, we've done 10, 9, 8, 7, 6. Could we use a 5 and get to 16? This is where it gets a little bit tricky, boys and girls, because if I want to do 5 and something more gets me to 16, I'd have to move all of these over. How much is this? 5, 10, 15, but then I would need one more. But how do you do that on a 20 bead Rekenrek? It's kind of tricky. So what I would do is I would actually not put this set all the way into play. These guys we're going to ignore because they're out of play, and I think I even have a Post-it. It's probably not big enough, but I can kind of cover them so we know we're not using those. So here you can see we have 5, and then we have this set here, which would be 10 and 1 more. You could say that 5 plus, what's 10 and 1 more? 11 makes 16. Wow, that's some tricky counting. I'm very proud of the combinations of 16 and 10 and 13 that you've made. For a challenge, we're out of time for our video, but I'm going to set up a challenge for you. See if you can find all the different ways to make 20. For 20, that would actually require in play and out of play, because boys and girls, 20 would be all of the beads. There's a wonderful 20 bead Rekenrek that you can use online where you can practice, or you can just make a Rekenrek out of anything you've got, beans or pebbles outside or pine cones, pretty much anything you could use. Buttons. Have fun and happy counting. Bye-bye.